Okay, welcome back everyone. Now we do have router-to-router connectivity through the link networks, but we can ping our neighbor routers, but we cannot ping our whole network of routers. Let me just pull up this network topology diagram. So, for example, router 4 can ping router 2, and router 3 can ping router 1. So, directly connected routers is no problem, but router 4 can't ping router 1, for example. And that's because routers automatically know about all directly connected networks. But if they need to know about other routers in the network, then we need to use an IGP, an interior gateway protocol. So we advertise our networks to the rest of the routers. And that's what we're going to do today. We're going to enable OSPF, so every router will know about the whole network, and then we can connect to the routers through the loopback addresses. Also, we are going to configure this remote syslogging. So all the router logs will be sent to this Linux machine and the syslog service. So we easily can see all the logs from the routers. And in order to be able to get syslog to work, we first must configure the IGP. So all the routers have access to this Linux machine. So that's where we'll start. If we go to my Linux terminal, I am still logged into these routers, at least I thought so. I think I need to reconnect. So it was 10.20.30.3, and we need to be root, and then we can reattach to our screen using screen dash small r, big U, and small d. Here we go. Now we are connected. I will log in to the router on each and every one of these. Like this. And I don't know if you have been using OSPF before. I will not go into the details in this lesson. I will just show how you configure it on XR and on regular iOS. So router 1 is connected to the server network on port 0, and then it's connected to router 2 on port 1 and router 3 on port 2. So the first thing we need to do is to enable the OSPF process. And then we type router OSPF, and then we give it either a name or a number to identify this specific instance of OSPF. In regular iOS, you put in a number from 1 and above. In this XR, you can use 0 and you can use text, but I will just use 1 on every one. The first thing I will set is the router ID. That's an IP address identifying the router on the network, and since there are multiple IP addresses to choose from, iOS XR will automatically choose the highest IP address bound to a loopback interface, if there are any, and the highest IP address of the entire system if there are no loopback interfaces. So we only have one loopback interface, and it will most probably choose the correct IP, but just to be sure, I always set the router ID anyway. So it's 172.16.0.1 for router 1. Okay, then we need to specify the OSPF area, and 0 is the root, the basis area, and that's what we'll use. And then we will just choose the interfaces which will be a part of the OSPF process. And that's basically every one of them. Usually I wouldn't include this server LAN network in the OSPF. I usually only put in the loopback interfaces and the link networks, and then I would put this LAN segment here into BGP. But since we're not using BGP at this point anyway, we will have to advertise this to the OSPF as well. So I will put gig 0000 exit and gig and the 1 interface, the 2 interface, and the loopback interface. And that's it. This is our OSPF configuration. It's very simple to do it on iOS XR. So we commit this config like this. And then we just move on to the next router, which is router 3. And on this one we have 2 links to router 1 and to router 2. So we'll basically do the same. Router OSPF 1, then area 0, int gig 0, 0, 0, 0, and 1. And finally the loopback interface. And we will also select the OSPF router ID like this. And we commit our changes. And then we go to router 4, which does only have 1 Ethernet link. And that is the gig 0 interface. And we'll include the loopback as well. There we go. Okay, so the 3 iOS XR 9000 routers are configured for OSPF. In order to do the iOS router, we will go into my Windows machine and my VMware Remote Console, like this. And the configurational steps is a little bit different on iOS, regular iOS. So first, my keyboard is a little weird with this console, that's why it's so many T's there. Okay, so we begin by starting up the OSPF process, and we give it the instance ID of 1. We select the router ID just like we did on the XR, like that. And then we define the network. And the network is an IP address that will tell the OSPF process which networks that should be included in the OSPF process. And in our case, all of our link network begins with 192.168. So I will input this, and then we will give an OSPF wildcard mask. So a wildcard mask is like an inverted subnet mask. So this is a /16 network, and this is the subnet mask, but we will turn it around. So instead of 255.255.0.0, we will do 0.0.255.255. And then we define area 0 like this. And what about the loopback interface? Well, we could do a network statement for that as well, but we don't want to do that because we don't want it to be fully integrated into the process. We do, however, want it to be advertised. So instead we'll do like this. We go into the loopback interface and we do IP OSPF area 0. OSPF process ID 1 area 0. That's the one. We save. So if we look at the LO0, we have this command, and if we do show run and pipe it to section IP OSPF, we will see, no, not IP, it should be router OSPF, and then we see the rest of our configuration. So if we do show IP OSPF neighbor, we see that the right router IDs were selected, and we see our neighbors, the other routers. We can also show the IP OSPF database, so we see what's been advertised. The router link states on the top is the different routers participating in the OSPF process, not just the neighbors but everyone, including router 2. And in the bottom we see all the networks being advertised into the OSPF process, and there we see the networks from the other routers, right? And if you do show IP route, we should see the whole network with all the OSPF routes, including this 10 network, as well as the different router loopback interfaces. So from router 2 we should be able to ping router 1's loopback address, router 3's loopback, and router 4's loopback, and we should also be able to ping the Linux machine. That didn't work, however. What about the VMware ESXi hypervisor? It doesn't seem to be forwarding packets to that network. Why is that? Or maybe, let me think, it's the packets go to that network, but they do not return because we don't have a way into this network. We need to change the default gateway of that 1020 network, because we're currently using the .254. I don't think we did change the Windows machine though, so perhaps we can still ping that one. No, I probably changed that as well, or it's disconnected. Okay, so we'll log into the Linux machine again and change back the default gateway to the .1, the router 1, and we will do the same with the hypervisor. However, I will lose the connectivity through this console if we do that, because there's no internet access before we have configured the cloud. And by cloud I mean this network, the outside network. But that's really no problem. We can still reach everything through my Windows machine. Okay, we can do a compromise. Instead of changing the default gateway on the Linux machine, we can add static routes. So static routes to the 192.168 network as well as the 172.16 network will be routed through router 1's IP, but the rest will be routed through the .254, which is my router on the outside of this network. Okay, that's a good solution. So we go to the, I'm not sure actually if we can do it directly in the etc. network interfaces. We probably could do that. 5 interfaces. Static. Method. Let's search for route instead. Never mind. We'll just do it manually. Okay, so if we do route-n, we see that we have a static default route through the 254. If we add route add and 192.168.0.0/16 gateway 10.20.30.1. Doesn't make sense with host route. Route add 192.168.0.0/16 gateway. Doesn't make sense with host route. Why does it say a host route? What am I missing? We probably need to add .-net so it knows it's a network and not just a single host we're adding. Yeah, that's right. Okay, so we'll do the same with the loopback addresses. And this is a /24 network. And that should be it, I believe. So can we ping router 4 from here? Yes, we can. It works like a charm. And can router 4 ping the Linux machine? 10.20.30.3. Yes, it can. Okay, so our OSPF is working. everyone has connectivity to everyone through the OSPF process. Next thing is to enable remote logging. So a couple of lessons ago we prepared the remote syslog service, but we did forget one thing. There is a directory called etc default, and here we have one file for the inet util syslog. By default it uses this no forward flag, but we want to enable the remote syslogging, so we change this to -r and save. If we do netstat and grep for UDP listeners, we have 69 at the moment, which is the TFTP server that we set up before, but we don't have any syslog. However, now that we have edited this default, so if we restart the syslog server, now we have port 14 listening. So if we check this etc services for 514, we see that it's a syslog. Okay, so now it's listening on the interface. Now we do have to make some changes to its regular configuration file. So we prepared local 3, the facility local 3. A facility is like a class of log messages, and we need to have one facility per router so the syslog server can put it into the right log file. I want to change this local 3 to local 1, so router 1 has local 1. It's easier to remember. I will also, we can do like this. So we will use local 2, local 3, local 4, and we'll match these with the corresponding routers. But if we make this change, we have enabled 3 more facilities. We need to exclude them from these debug and messages files. At the moment we have an exclusion for local 3, and we need to add an exclusion for the other ones as well. So we type in a star dot and exclamation point, and then we type in local 1 and a semicolon, and then we paste this to 1. Oh. We copy this and we paste this like this, so we have 1, 2, 3 and 4, and we need to change the number, so we have 1, 2, the 3 is already there, and 4. And same on this messages portion. So let's input 1 and 2. We have 3 already and 4. So we have 1, 2, 3, 4. We save this file and we will not like this. We will restart the syslog again. Like this. And now we'll go to the varlog network directory that we created last time. And we'll check the contents of this directory. Here we are. We have 4 different files, 1 per router. Now the Linux end is done. We will do the routers next. So it's quite easy to enable remote syslogging. Let's just log into the routers. The first thing we need to do is choose the facility. So we do logging, facility, and then we choose local 1 for this router. And then we just do logging and the IP address of the logging server, which is the Linux server. So that's 10.20.30.3. And then we give a severity, that's log level. In iOS we can just type in 5 for the log level 5, but in XR we need to use these labels. So notifications is the same as 5. We'll do like this, and we commit. Then we need to do something that makes a log event. So we need to change something. We can do like mpls ldp commit and no mpls ldp commit. Something like that. Now, if everything is working as we intend it to be, we should be able to go into the Linux server and see that the file for router1.log has grown a bit. And it has, but also router 3. That's a bit weird. Because we are using local 1. And here we have the configurational step. What about router 3? So one of the syslog events ended up in the router 1 file and one in the router 3 file. Did we forget to change something in the syslog file, perhaps? We'll check out the syslog.conf. We have local 1, local 2, local 3, local 4, and we have router 1, router 2, router 3, and router 4. No, we haven't done anything wrong with regards to the syslog configuration file. Then it must be the router itself that sends one type of the logs to the server as one facility and something else with another facility. Why is that? Perhaps it didn't have time to update the facility, and that's why it happened. We'll see. We'll monitor that situation and circle back to it. We'll do the rest of the routers first. So router 3, we do logging, facility, local 3, and logging 10.20.30.3, severity notifications commit. And we go into router 4, and we do logging, facility, local 4, logging 10.20.30.3, severity notifications, and commit. Okay, that's all the XR routers. Then we will do the same on the iOS router. It's the same basic principle, we just used quite different commands. So first we do logging facility local 2, and then logging to 10.20.30.3. No, that's not right. Logging, yeah, it's right. 10.20.30.3. Unrecognized command. Maybe it's just like this. Yeah, okay. So what about the severity? Maybe we just put a 5 there. No. Logging. What do we have? So we have the facility logging on. Logging hosts 10.20.30.3. Here we go. Discriminator, filtered sequence, session ID, transport. Let's check how the running conf looks like. Section logging. Because we can have logging console, we can have logging monitor, we can have logger buffered. Somewhere we should be able to set the severity level. Maybe it just logs everything by default. If we save this and we go to the Linux server, now we start to have log material in all of them. Even router 2 which is the iOS router, so it works. What about router 1? There we have this one, okay. And router 4 we have this, and router 3 think it works. Let's generate a log in router 1 again and see what happens. So we'll just do something like we can do mpls-lp again. Sit net no mpls-lp net. Okay, so did any of these log files grow? Router 1 did, that's expected. but no of the other ones. So the thing at the beginning was just a temporary thing. Now we have syslog set up for the whole network, and it's very neat to have one specific log file on the Linux server for each and every one of these routers. We should, however, set up one more thing. There is something called log rotate, because these can be very big after a while, these log files, and we want to rotate them. By that it means like when it has been logging for 1 day, it creates a new file and start logging to that. So it's 1 day per file, and then you can tell it to save 10 files and then start removing the oldest one, so you don't fill up the entire hard disk space with logs. You can also zip them together so they don't use up as much space. So if we go to log rotate D and we check one of these files as an example, we have one for initutils actually. If we open this one up, we have one for auth-log, daemon log, debug, kernel, mail. All of these standard Linux log files, we already have one section. So if we just add one, let's do it like this. This is 1, 2, 3, 4, 5, 6, 7, 8 lines. So we do 8 DD and we paste it back, and then we also paste it down here. Okay, so I'm not sure if we can do a whole whole directory like this. Let's check the manual. Log rotate log rotate.conf. And we search for directory. If a directory is given on the command line, every file in that directory is used as a config file. No, that's not right. Last section is tile expansion to rotate log files in the home directory of the current user. This is only available if your glob library supports tile expansion. GNU glob does support this. Tile expansion. Star.log. Yeah, we can use the star. Okay, so network star.log, rotate 4. I want to have 10. Listing okay, notify, empty, weekly. Daily. Compress, delay, compress. Okay, this looks right. And then we restart the log rotate, I would suppose. Oh, perhaps not. So what if we go into the var log network and we do log rotate. I don't think we need to do anything more than this. I would, however, want to check somehow that it works. What if we just type in something like log rotate, log rotate D in utils syslog. Okay, it doesn't show much. What if we do like this? Okay, so considering log file R1 log, last rotated, log does not need rotated. Probably because it's small and it hasn't gone a day by quite yet. So we'll just see. If we check this tomorrow, there probably would be a file called like r1 log.0 or 1, and then it will start zipping them as well. Quite useful function. You should always use the log rotate when you have any logging in your system, because you don't want it to fill up your root partition. Okay, so today you have learned how to use log rotate, but also how to configure remote syslogging on a Linux server, and how to configure the same in the Cisco IOS router and the Cisco IOS XR routers. In addition to this, you have learned how to configure an IGP. We have used OSPF, and how you configure it on the iOS XR routers as well as on the usual iOS routers. So thanks for watching, and thanks for today.